The MFPH Next Generation Seminar Series is a networking event for early career scholars, junior modelers, epidemiologists working on or interested in mathematical modeling of infectious diseases and other threats to public health. Bienvenue à tous. La série de séminaires MFPH Next Generation est un événement pour les chercheurs en début de carrière, modélisateurs juniors, des épidémiologistes travaillant ou intéressés par la modélisation mathématique des maladies infectieuses et d'autres menaces pour la santé publique. First of all, we wish to acknowledge the land on which the Fields Institute operates. For thousands of years, it has been the traditional land of Huron-Wendat, the Seneca, and Mississaugas of the Credit. Today, the meeting place is still the home to many indigenous people from across Churchill Island, and we are grateful to have the opportunity to work on this land. Premièrement, nous souhaitons reconnaître cette terre sur laquelle l'Institut Fields opère depuis des milliers d'années. C'est la terre traditionnelle des Huron-Wendat, des Sénèques, Mississaugas. Aujourd'hui, ce lieu de rencontre abrite encore de nombreux peuples autochtones de toute Churchill Island, et nous sommes reconnaissants d'avoir l'opportunité de travailler sur cette terre. Our guest today for the first talk for 2024 is Dr. Elda Laison. She's a PhD student at Public Health School, University of Montreal. Elda holds a master's degree in infectious disease modeling and machine learning, and she is a medical doctor from Havana University in Cuba. Her main works are on the application of machine learning and artificial intelligence in public health. Notre invité aujourd'hui, c'est Dr. Elda Laison, doctorante à l'École de santé publique Université de Montréal. Elda est titulaire d'un master de modélisation des maladies infectieuses et en apprentissage automatique. Elle est médecin de l'Université de la Havane, Cuba. Et ses principaux travaux portent sur l'application de l'apprentissage automatique de l'intelligence artificielle en santé publique. Her talk will be today on identification of potential Lyme disease cases using self-reported worldwide tweets, a deep learning modeling approach enhanced with sentimental words via emojis. Sa présentation portera sur l'identification des cas potentiels de maladie de Lyme à l'aide de tweets dans le monde entier, une approche de modélisation d'apprentissage en profondeur renforcée par des mots sentimentaux via des emojis. Thank you very much for accepting our invitation, and the floor is yours.
Thank you, Luis, and thanks. Welcome to everyone. I'm very honored to present my work here. So my presentation is based on my master thesis, and the title is Identification of Potential Lyme Disease Cases Using Self-Reported Worldwide Tweets, a Deep Learning Modeling Approach Enhanced with Sentimental Word via Emoji. So I'm a candidate for a PhD degree in public health at University of Montreal, and I'm supervised by Professor Bushra Nasri. And this work was done in collaboration with Mohamed Ibrahim, Madhu Diop, Austin, and all my colleagues that are listed here. So first of all, I'm gonna start with an introduction about what is Lyme disease. So Lyme disease is a tick-borne disease, and it's considered to be the most common vector or tick-borne disease in North Hemisphere, including European country, North Asia, and North America, United States, and Canada, where the disease is most common. So it's transmitted by tick which are part of the Exodus type species, and all the ticks phenology are specific to geographic region, and it is bacterial. It is transmitted through a bacteria, and it's been more and more like it's becoming a public health concern because of the increase in incidence of Lyme disease, mainly due to global warming, which allow ticks to expand in their geographical range. The Lyme disease normally have three clinical phases, but it actually run asymptomatic If so, it will appear with cold flu symptoms such as flu, headache, asthenia, and all. But it can actually run with a specific symptom, which is erythema migrans, which is a specific rash which can appear in skin in 70 to 80% of cases that have been reported. And despite antibiotic treatment, which is the treatment for Lyme disease, 10 to 20% of the cases will go transit to a chronic phases, which doesn't have a proper treatment available. So traditionally, Lyme disease, it is a notificable disease in North America and some European country, which is has to be reported by the healthcare professional. And that system of reporting Lyme disease has found to be inadequate to accurately track all cases, mainly because sometimes healthcare professional may forget to report it, or because of uncertainty of if this is actually through cases of Lyme disease, it may go unnoticed. So most of the cases being reported, it has been estimated that there's non-reporting. An example of that is in 2021, CDC has reported over 30,000 cases of Lyme disease in United States. However, another article which was based on health insurance claiming has reported that Lyme disease cases can be estimated at over 400,000 cases of Lyme disease in United States alone. And United States hasn't been the only country with the alleged underreport of Lyme disease. Also, Lyme disease diagnosis is through a 2-tier ELISA test, which has its own, which is not very, which has some deficiencies because the disease, we need to assess the disease or have a proper diagnosis in the first 72 hours so that the treatment, the antibiotic treatment can be effective. However, the laboratory disease diagnosis tests available to identify Lyme disease is not very sensitive in the first 72 hours. So we have to wait at least 1 week to have like a proper diagnosis. So most of healthcare professionals will start the treatment without backing it up with a proper Lyme diagnosis. One of the methods that was proposed to complement or as a complementary tool to the already traditional surveillance system in Lyme disease epidemiology has been epidemiology. So epidemiology is a monitoring system which is based on using trends from internet search to predict or to monitor an infectious disease incidence or epidemiology. So in this case, we use Twitter data for several reasons, mainly because Twitter data, Twitter, which is the actual X social media platform, because Twitter data is quite easy to access via the Twitter API, which allow you to collect freely 1% of a daily tweets available worldwide. You can collect at as much as 1% of a specific topic. Also because Twitter do allow you to access some available geolocated tweets, which is good if you want to study spatial or temporal distribution of a specific disease. And also because in 2019, a research was done using Twitter data to assess or to monitor Lyme disease in the United Kingdom and Ireland Republic. And it was successful or accurately predict spatial distribution of Lyme disease cases when it was compared to official report of Lyme disease in those countries. So that was the main reason we use Twitter data. So the main objective for this article, it was to provide an accurate English word. So we wanted to collect or assess to have a data set with English worldwide tweets about Lyme disease. And also we wanted to evaluate the performance of selected transformer-based model when including or when integrating emotional components with emoji to see or to assess if incorporating emojis will enhance the performance of the selected transformer-based model. And as specific objective, we try to analyze the performance of several prominent natural language processing NLP classifier to determine the ability to predict potential cases of Lyme disease. We also evaluate the effects of incorporating emoji as enrichment feature to improve the performance of transformer-based classifier. Then we explore the tweet count to determine whether specific pattern could be identified regarding the prevalence of Lyme disease for each country. So first of all, to collect the data from Twitter through AP Twitter, we had to select or to choose a keyword that will that we can use to assess or to collect data that related to Lyme disease. And based on literature review, it was assessed that common or general word about Lyme disease was sufficient to actually extract Lyme disease data sets, such as keywords such as Lyme disease, tick were enough to assess it. But we wanted to make sure that the data we are collecting was actually about Lyme disease. So what we did is we actually had we classify our keyword in two categories. So we have the mode of acquiring Lyme disease, then we have symptom and Lyme disease symptom, like specific symptoms from Lyme disease. And then we have the more we incorporate also common phrases that can mean that the person was referring or talking about Lyme disease. So in this table, when it comes to mode occurring Lyme disease, we try to use keyword that was used by most of people. So we didn't use quite medical term or specific medical term to assess the mode of transmission of Lyme disease, to make sure we are capturing every possible tweet about Lyme disease. So these three categories allow us to assess all those keywords, and all those keywords was the keyword that we selected to include or to collect our data set. So to assess the data set, we choose our time frame from 2010 and 2022, making sure that we only selected English tweets. And after we collect the keyword, so what we do then is a filter or clean our data. So in order to clean our data, we have to remove a word or empty words such as hashtag. We have to remove HR or a URL link, HTML markup, stop word. So with username, to make sure that our data set is quite anonymous, so we remove all the username, all the retweets, so that we don't have the same information over and over again. So we clean our data set, and after that we have to convert our emoji into word, because the emoji can mean a lot of things. And also through literature review or research, we realized that in order to have the best use of emoji when it comes to sentimental analysis. It was better to switch or to have the meaning, the textual meaning of emoji. So that's what we did. We convert the emoji into the world or the sentimental or actual textual meaning of those emoji. And then we incorporate it into our data. So after that, we separate our our data set into 3 data sets. So we have our training data set, the validation data set, and then our testing data set. So in all after cleaning, after converting and all, we were left with 20,000 English tweets from 2010 and 2022 worldwide, with a very high percent of United States tweets, because we realized that almost 90% of our tweets were mainly from United States. The reason being that United States is one of the main population when it comes to Twitter population, user population. So it kind of makes sense, but we make sure that in our data set, it was only about Lyme. It was only United States that was mainly in our data set. So we had to make sure that 10%, at least 10% of our data set were from other English country worldwide. So then after that, we selected various NLP, so natural processes languages, to train that we train with our data set, and then we saw the one that performed better. And then from the one that performed better, we actually add the emoji to it and assess if the emojis or textual sentimental twister from emoji can enhance the performance of those models. So after that, we have also, when we're training our data, we have to label our data. So what we did is we use a binary classification when we assess a label 1 to assign potential Lyme disease cases. And then we assign 0 to those that were not, that we didn't consider to be directly that were directly related with Lyme disease. So out of those 20,000, we manually label 6,000 from those tweets manually as 1 and 0 to assess it. And then we use 2 methods to specific keyword. So we actually use the first one to investigate the content of the clean Twitter to determine the relative frequency of common Lyme disease words. So such as I have Lyme, I had Lyme, having Lyme, got Lyme, and tick, bite there, tick there. And then after that, we actually do that to make sure that when we see or Twitter tweet posts such as she is terribly unwell, we suspect it is Lyme, it can be labeled as a potential Lyme disease, such as, and then the second method that we use was involving or considering most frequent Lyme disease symptoms. So the 3 categories that we actually have. So if one of those keywords appear in a sentence or in a tweet, we label them as a potential Lyme disease cases. So that manual approach is actually important because it will ensure that we have a fair and accurate labeling of the data sets. Because when you automatically label tweets, especially when you do it in Python regress library, it does not always provide correctly labeled tweets. So it was necessary to go to the manual classification before the automatization. So, okay, from the 20,000 clean tweets, we split them in three. So training, validation, and testing. So we actually have 12,000 that we randomly select from 2010 to 2022, and it serves as the training data set. And then we have 1,000 tweets that we select randomly throughout the year. So the 12,000 that we have in our training data, 1,000 of each correspond to one of the year that we select, so 2010 to 2022. And then those tweets, we furthermore divide or distribute them into two classes, 6,000 as a potential Lyme disease cases, while the remaining 6,000, we assess or label them as not related to Lyme disease. Then the remaining 8,000, we separate them into equal part, making 4,000 in each validation and testing data set. So this table, this figure is the two-stage approach that we use. So we, after we clean, after we manually label, convert emoji into sentimental, and then the second phase was to use a transformer-based classifier to determine whether a tweet is a potential Lyme disease cases or not. So when the model classify a tweet or assign a tweet as a potential Lyme disease case, then we will use the DUP, which is a library in Python to estimate tweet location. We will use it to assess the location and then geolocate it and set it as an alert. And then after that, we compare it with the report to make sure that this is actually a good classification or not. So we actually the process to determine whether a tweet is about Lyme disease is when we have our main tool, then the training and the validation data set. We will use a fine-tuned and pre-train our transformer. We pre-train our transformer-based classifier, which can identify whether a new unknown tweet is a potential Lyme disease. So after using the training data set to train our classifier to be able to detect a potential Lyme disease or not, then we'll use our training and validation data set. Then after that, we will use our testing and validation data set, which have unknown tweets. And we will run it into the model again to assess or to see if the model is able to identify a new unknown tweet as a potential Lyme disease case. So the reason we use a transformer-based model and not others such as a TIFI-ID or a random forest logician regression is because in the recent literature, it has been found that transformer-based model have been highly efficient in to accurately or estimate or classify a case as being accurately classify a case as a potential case or non a potential case. So what we did in our study is we use a bidirectional encoder representation from transformer BERT model, which was developed by Google Intelligent Artificial Language in 2018. And we use it to one of the main or one of its way of working is that it will allow it has a representative in both ways, so it can read a sentence or it can read a token you insert from right to left and from left to right. So is actually able to predict or to accurate you can pre-train it to predict next sentence, for example. So he actually have the ability to adjust to adjust in parameter to be able to predict next sentence based on this sentence while reading it right to left or left to right. So so one of the main advantages of BERT classifier is that it is trained to understand tweets, specific tweets, semantic content, and it can actually generate word embedding representation. So when we actually clean our tweets, we fed it into those BERT classifier, and it was able to convert those tweets into sequence of tokens. And we use the three most common, which is the CLC from our model, the CLC, the SEP, and the PAD. Those were the three transformers of BERT we used to pre-train our model. So yeah, and after that from the BERT classifier, the one we used the most was the distilled BERT, the Albert BERT, and BERT tweets. Why did we use BERT tweets? Because we're using data from Twitter, so it was actually easier for us to use a BERT or a bidirectional coder transformer that was specifically trained with data from Twitter. And then one of the main advantage of a better tweet is because it was trained with tweets related to COVID-19 pandemic, and it was actually it was actually trained to detect or to classify tweets from Twitter. And then we use distilled BERT. Distilled BERT is actually a variation of BERT, but its advantage is very small. It has fewer parameter, and is actually able to it is actually able to perform way faster than a normal or conventional BERT model classifier. And then we actually selected or actually decide to use the Albert also because Albert has it actually has the capacity actually to is smaller also than a normal or general BERT or BERT tweets, but is as efficient as a BERT. So those are the three classifier that we use. We didn't only use BERT classifier, we actually incorporate also NLP or traditional NLP classifier, such as a TF-ID, random forest, logistic regression, and all to assess actually the accuracy of our we wanted to make sure that BERT classifier were the best performance when we compare it to all the NLP or most of the NLP classification models. So here we assessed three from our text data set, which is the accuracy. We assess the accuracy, we assess our F1 score, we assess precision, and we assess recall. So first of all, what does the F1 accuracy is actually the capacity of the capacity of our model to accurately classify a tweet as a potential Lyme disease cases or not. And as we can see, the BERT tweets model was the highest or has the best accuracy of 90% accuracy, which means it was able to accurately classify tweets as a potential Lyme disease cases, and 90% of the cases. to actually ensure that there's a consistency in results across evaluation and all of that, we use the same training, validation, and data set for all the model that we build. So what we were trying to do is we use our learn classifier to predict tweet label during testing phase, and then we record the confusion matrix on the testing data set so that we were able to capture the proportion of actual Lyme disease that were correctly classified as a potential Lyme cases, the proportion of actual non-Lyme disease correctly classified as unrelated to Lyme disease, which is known as the true negative. Then we wanted to know the proportion of actual non-Lyme disease tweets and correctly classify as belonging to potential Lyme disease cases, which is known as false positive. And then the proportion of actual potential Lyme disease tweets misclassified as non-Lyme disease tweet, which is known as false negative. So what we do is we compute those several evaluation metrics to actually be able to capture a correct prediction, which is the true positive and true negative among all examined tweets, the average F1 score. The F1 score quantify the likelihood of correctly identifying a Lyme disease tweet as a Lyme disease tweet, and then the precision and the recall, which will quantify the proportion of correctly identifying tweets that are actually potential Lyme disease cases and vice versa. So in this table, we can see that when it comes to the accuracy, so to actually accurately classify a tweet as one, when it comes to quantifying the likelihood or correctly identifying a Lyme disease tweet, and when it comes to quantify the proportion of correctly identifying a tweet, BERT tweet model tend to perform better than all the rest. We saw that after the BERT tweets, also all the rest of the BERT classifier, such as distill and BERT tweets, were actually Sil and Albert were the follow BERT tweets in like high evaluation metrics to accurately classify, to actually identify and properly classify a Lyme disease tweet. We realized that BERT was the best performing of all of them. Okay, so we actually in our second a specific evaluation objective, which was to evaluate the emoji or the integration of emoji as an enrichment feature to see if it will improve the performance of our BERT classification. When we actually incorporate emojis into our data set and emoji expression as a contextual encoding and classifying and classification of tweet, as we can see, we can see that BERT tweets in this table again has the highest performance among all the three. In this case, when we include the emoji, we only consider the three most performing model, which was the three BERT model classification that we've used. So the BERT tweet, the Albert, and the distill BERT. So here we can see that when we actually incorporate emojis, the accuracy of the model, BERT still perform the highest, but the accuracy and the F1 score and the precision and the recall actually improved. So instead of only having a 90% accuracy, when we incorporate emojis, the accuracy went from 90% to 95%, 95.2%, and the F1 score went from the F1 score went from a 89.3 to 94.9%. The precision went from 97.1 to 90.8%, and so on. So this shows that this actually permit us to be like to assess that when we incorporate emojis, specifically in this case, when we incorporate emojis as textual sentimental text into a data tweet data set, it can actually be an enrichment feature because it tends to improve the accuracy of the classification. So the third objective of our study was to explore to set if we can explore if we can explore the collected data to determine if we could identify certain patterns, certain epidemiological pattern. So here we wanted to search for the top medical symptom of Lyme disease to actually make sure that does it correspond to the literature. And what we found that first of all, our tweets were generated from a lot, in total 46 countries that we can access. It was accessed from 46 countries or from all over the world, US being the most prevalent, followed by UK, Canada, Australia, which actually have the highest when it comes to English-speaking country and the incidence in Lyme with English-speaking country with prevalent Lyme disease cases. So we actually saw epidemiological pattern when it comes to the country that was generating the most tweets about Lyme disease were actually country where Lyme disease were or tend to be prevalent. However, there are some countries in our research that actually that doesn't have any like reported Lyme disease case yet, but we saw 1 or 2 Lyme disease cases that were being like tweet about Lyme disease in those countries, but almost 97% of those country generating Lyme disease were actually country where Lyme disease were prevalent. And also when it comes to the symptoms, I've talked about it in the beginning, the introduction. Lyme disease, one of the characteristic or particular symptoms about Lyme disease is the rash, which is known medically as erythema migrans, but commonly it is called rash. And rash has been the most symptom that was reported, which actually correlates with what is found in the literature, because rashes tend to be present in 70 to 80%, follow with cold-like symptoms such as fatigue, fever, migraines. Those were the most reported symptoms when it comes to Lyme disease related to it. So that's when it comes to the limitation of our studies, I think is, even though like internet research or social media platform can give us a good data that we can run or work with when we are trying to better understand or to assess epidemiological pattern of an infectious disease. We still have to remind that, first of all, when we use Twitter, even though Twitter give us a good content, Twitter, one tweet can have up to 280 words, which is enough to have the information we want. And also we can actually have 1% of a daily tweet of every daily Twitter data set, which is enough. It's still we still have to we still face the selection bias because only 1% of that is being accessible to us. In a better or in ideal condition, it would be better to have the whole data set so we can actually run it and make sure that we have all the information. That is one of the limitation of our study. We didn't use the whole data, we only used the one that was provided through AP Twitter. So we probably missed some, but we do believe that because we just didn't set up with 1 year or 1 year data set, we actually make sure to have up to 12 years 12 years worth 1% of Lyme disease related tweets. We do believe it will or it may reduce considerably that selection bias. Also, one of the main limitation is that when we use any data from social media and internet search engine, is that social media is highly susceptible to media coverage. Actually, when it comes to Lyme disease has been quite highly spoken in media because some celebrities may have it because of the chronic phase of Lyme disease that still is a controversial topic around researcher. So because of that, Lyme disease has been quite a high topic in some years. So that might actually be one of the reasons that we have some years may have more data or not, and some data may not quite be related to cases, but actually people inquiring or being curious about diseases, not because people are suffering or people are reporting Lyme disease cases. Also, one thing that should be known when using social media data to assess epidemiological pattern of an infectious disease is a tweet or a post about a disease is not equal to that disease cases. So that's why in the beginning we say epidemiology can be used as a complementary tool when it comes to disease epidemiology, but it should or it can, at least as up to now, cannot accurately replace a traditional surveillance system, but it can actually give us an idea about where where around the world this disease has been mainly spoken about, and it can actually give tools to researcher or public health official to actually have more promotional or campaign about the disease or know where the disease is being discussed about the most. It can give an idea, and actually having that data set can actually be a good a good data set or a model like this. It can actually having a data set about a collected and clean tweet about atopic disease somewhere is good, because at least when we are trying to build a model or NLP classification model about Lyme disease in the future, well, the data is already there. It can be, we can add others classification, we can add we can add other social media or platform data set, others internet search data set to it, but this is actually like a platform that is already available to most people that would like to go onto the epidemiological aspects when it comes to Lyme disease to see if it can improve. It can actually be featured with a traditional surveillance system to see if it can enhance it, if it can actually give a better prediction, if it can actually assess an under-reporting or an over-reporting of Lyme disease in this case. So I think, so this is the the references, some of the references from the talk today. And thank you for listening to me. And if you have any question or suggestion.
Thank you very much for this great talk. If you have any